everyone, we're going to work through an example of how to write the equation of a tangent line to a polar curve at a specified angle value. This is a problem we had seen in an earlier example, and we're going to pick it up from the point at which we had already found that the slope of this particular polar curve, r equals 2 plus 4 sine theta, at the theta value of pi is equal to negative 1/2. We all know that in order to write the equation of a tangent line, you have to have your slope first. So we can pick it up from that point. The next thing we need, though, is the point on the polar curve, and we do need the point x comma y. In order to find the point x comma y, we do need to use those two little equations we've seen earlier, that x equals r cosine theta and y equals r sine theta. Substituting the angle pi into the given polar curve, r equals 2 plus 4 sine theta, we'll need to first determine r. Knowing that sine of pi is 0, we find that r is equal to 2. That will now allow us to find the x and y values we need. You might remember doing this in an earlier lesson. So now we have that the point we need in terms of x and y is the point negative 2 comma 0. And so now we have a slope, we have a point, and we can go ahead and find the equation of our tangent line. We're going to substitute into point-slope form of a line as we always have done. So we'd have y minus 0 equals that slope we found, a negative 1/2, times the quantity x minus a negative 2, so that becomes, of course, x plus 2. We'll go ahead and simplify this. And here's the equation of our tangent line. Now this is in rectangular form, obviously. We could go ahead and continue on to find the equation of the tangent line in polar form, and we're simply going to use those formulas we know from before. So if we wanted to continue on, in place of y, we could put r sine theta. In place of x, we would have r cosine theta. I think I'm going to multiply through by 2 to eliminate that fraction. And now it's simply a matter of gathering the terms that have an r in it on one side of the equation so that we can eventually solve for r. And factor out that r, and we find in the end that r is equal to negative 2 divided by the quantity 2 sine of theta plus cosine theta. That then would be the equation of the tangent line in polar form. So now, one thing you could do is graph the original r function on your calculator. You can now also graph this tangent line equation in polar form, and you will actually see the tangent to the curve at the point where theta equals pi.